Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 17 of the January daily LeetCode challenge, and we again have a medium question in front of us. I guess this is the third question that we're having on the topic of bit manipulation. Okay, this is very interesting question, and my recommendation to you will be, if you have not seen yesterday's question, okay, I'm talking about day 16 daily LeetCode challenge. That is yesterday's question. If you have not solved that, please do that. And I'm damn sure if you are solving that after knowing the details, after knowing the tricks involved, this question will be nothing for you. You can solve this within 5 to 10 seconds. Let me tell this very frankly, this is a very easy question if you know the topic involved, if you know the trick involved. Okay, so this is very much linked with yesterday's question, so please do that. Okay, though the name doesn't seem to show the name doesn't show a link with previous question, but still I will say the topics are related, and especially the tricks are related. Okay, please do that once and then come back to this question. You will see the link. Okay, then you will like really feel that motivation to solve this kind of questions. Otherwise this will be looking like a bit of, I can say, tricky question for you. Okay, as simple as that. Now coming to this question, it is 2683. I'll be showing both Python and Java solution, as well as I've done a lot of my homework to show you and explain you everything in detail. Okay, let us start with this question. It is 2683, neighboring bitwise XOR. The question is a bit difficult to understand in the, if you see the theory part, but anyway we will see the whole the actual the calculations that are being involved. But for now, let us quickly solve the theory part also. Okay, let's quickly go through the theory part also. So a zero index. Okay, first see what we are given. We are given a derived array. Okay, the array name is derived. It's a binary array. Okay, it will be having zeros and ones only. See the range. It is going to be up to 10.5 length. Okay, and derived array is a binary array, so only zeros and one will be present in that. Okay, that is the input given to us. Now the output has to be boolean one, right? Now see this part. A zero index array derived with integer n is derived by computing the bitwise XOR of addition elements in a binary array original. Okay, of length n. Now they are saying two conditions. Okay, now for derive, see, we are we are given a derived array, but this derived array is coming from a original array. Okay, we are doing some calculations on the original array to get the derived array. Okay, as similar as that. But remember, original array is not given to us. Okay, we'll have to like generate it if we want. Okay, but this is not given to us directly. Now how the calculation being done? So see here, we are now trying to get how, we are now trying to see how to get the derived array out of the original array. Okay, remember derived array is already given, but they're still showing the calculations of how it is coming. Okay, so see this part. If I, that is if, okay, do not see this part because this is for the last index. This will not make sense to see in the starting. See the below part. See derived of I is equal to original of I XOR with original of I plus 1. Okay, original of I XOR with original, that is for every index I. Okay, take the next value, that is the for example, I want the ith value in the derived array. What you have to do, take the ith value in the original array, XOR it with the next value, that is the neighboring value in the original array. Okay, so I and I plus 1, you have to XOR them. Okay, as simple as that. Now since for every I we are taking the next and we are doing the XOR, so for the last, that is if when we are the last index, that is when we are at n minus 1, what we have to do, we will have to take I like this. We took here the same thing we did. The only difference is, instead of taking I plus 1 now, since this is the last number, we have to take 0. Okay, that is the first I can say element. Okay, first element of the original. Okay, so this is the only difference coming for the last index. Okay, that's the only exception for the last index. Now given an array derived, your task is to determine whether there exists a valid binary array original that could be formed, that could have formed derived. Okay, return true if such array exists, or false otherwise. Okay, a binary array is an array okay, fine. So this is the derived array, and you will have to say whether it is possible to have a original array for which, from which this array is derived. Okay, as simple as that. So see, they have given example here. See this part. So what you have to do, see this part. In, if you do XOR of this and this, okay, you are going to get a 1. Okay, similarly if you do XOR of 1 and 0, you are going to get again 1. And similarly yeah, this particular one. And if you do XOR of this particular value and this particular value, you are going to get 0. So we can say that yeah, there is a proper original array possible. For that reason we are getting true as the answer. Okay, same is the case for example number 2. For example number 3, it's a, it's a false value. So we will discuss example 1 and 3 in detail. Okay, now see this part. First I'm going to explain the example 1, and then we'll see how to apply this logic in example 3. Okay, now see this part. Let me zoom in and let's quickly begin. Okay, so this is my example 1. So in example 1, what we are given, we are given the derived array. Okay, so we have to assume that there exists original array also whose value is going to ABC. We'll see if it is possible or not. For now we are only going to give the variables here. Okay, so original array is equal to AP and C. Okay, A, B, C are variables. We'll try to see what are the properties of that. Okay, so as per the logic of the question, what we are getting, see, if you do XOR of A and B, what you are going to get, you are going to get this one. Okay, so A XOR B is equal to 1. Similarly B XOR C is going to give you this particular value, so we are just writing B XOR C equal to 1. And then C, okay, XOR with A is going to give you 0. Okay, so we are just writing that also, right? As simple as that. Now The pattern that I discovered here, see, till this part, everything is given in the question. Now your job starts to, monitor what is happening and to identify if their pattern is being formed. See, I can identify pattern. See, because I have, because I have solved yesterday's question very, properly, and I've learned something from that, so I can see the pattern now. Okay, see this part here, A is present two times. Okay, here B is also present two times. So whenever you see something present two times, what you have to do, in order to cancel them, you have to think about XOR. Okay, XOR of a number with itself gives to zero. Okay, leads to zero. So what I am doing, I am multiplying all the LHS. LHS means the left hand side. I am multiplying all the LHS terms together. That is, I'm taking XOR of all the LHS terms together. Okay, so this is the XOR of all the LHS terms. Similarly, for all the RHS terms, I'm going to take XOR. Okay, I'm going to take XOR. So this is the XOR of the RHS terms. Okay, now let us simplify it further. So since XOR doesn't depend on the order, that is, if you see A XOR B and B XOR A are the same. Okay, and that is, the order is not important. For that reason, now we are going to reorder the terms here. Okay, we're now going to reorder the terms. So see this part, here A is present, here A is present. I am now going to bring them together. Okay, similarly there are two B's, so all the B's I'm going to bring together. Similarly there are two C's. Okay, so C is also present two times, so I'm bringing the C's together. Okay, now the XOR result, what is the XOR result of this? See this part, 1 XOR 1 is 0. Okay, remember, you have to learn about XOR also. If you're not sure what is XOR, please watch previous days videos. I've explained in detail. Remember, this is the day number 3, so you cannot expect to learn the basics only in this video. You should be knowing the basics. I will advise that please go to 2 days back and try from that question onwards. Okay, the I can say the day 15th question onwards, because that was the first question we had on bit manipulation. There we had explained all the basics in detail. So because we have explained those in details in this question, because it's a slightly harder level, so we are not wasting time on again learning about those basics. Okay, so if you are feeling that okay, this is not something that I can understand, please do a Google search on what is XOR, what are the properties of XOR, and then maybe come back and see this video. Okay, when you are seeing this video, I am expecting that you would have seen my previous videos of day 16 and day 15. Okay, at least you would have solved those questions, or you would have at least seen the answer or understood the topic. Otherwise, this will be challenging for you if you have not done yesterday's question. Let me be very frank on this. Okay, so see this part, what is happening, I am resolving I am simplifying these terms. Okay, now since a number is being XORed with itself, so it will lead to 0. Okay, whenever a number is XORed with itself even number of times, the result will be 0. Okay, so this will be 0. Similarly, the B XOR B also will be 0, C XOR C also will be 0. So in the LHS, I am going to have all zeros. In the RHS, I already have a 0. For that reason, I can say that LHS equal to RHS. Thus this is possible. Okay, whatever be the value of A, B and C, but still this is going to be possible. Okay, irrespective of what is the value of A, B and C. Remember, you can take any possible value of A, B, and C which satisfy this condition, but ultimately, if you see these conditions will always satisfy irrespective of what is the value of A, B, and C. Okay, as simple as that. For that reason, it doesn't matter much. See, we are only bothered about whether the original array is possible or not. So in this case, it is possible. Now I will say, okay, like how we can say like that, this could be wrong, and something like that we will say. For that reason, I have also done the calculations for example number 3. Now see this case for example number 3. Okay, so I'm at example number 3 now. Okay, this is the derived array, as you can see here. This is a derived array. Now we have assume something here. This is my A and B for the original array. Okay, so as per the principles, what we have to do, A XOR B leads to 1. Similarly, B XOR A leads to 0. Okay, B XOR A leads to 0. Okay, first of all, this is not even possible. Okay, see, A XOR B and B XOR A has to be same. This is the point number 1. Okay, it cannot be different at all. Okay, point number 1. Next, let us proceed. We will do the XOR of all the LHS terms. Similarly, we'll do XOR of all the RHS terms. Okay, so we are doing the XOR of LHS terms, we are doing the XOR of RHS terms. Since RHS is the binary value, these are not variables, we can find the answer for that. 1 XOR 0 is going to be 1, and we are simplifying the terms for the LHS. Okay, since a number is multiplied with itself even number of times, it is 0. Similarly, B is multiplied with itself even number of times, it will be 0. So 0 XOR 0 is equal to 1, but 0 XOR 0 is 0. Okay, so we are getting 0 is equal to 1, which is not possible. So LHS is not equal to RHS. For that reason, we say it is not possible. So we are returning false as the answer. Okay. Okay, this is the basic idea in this principle. Now if you see, still I have not explained the whole idea to you. Okay, see, I have explained you in terms of examples, but how you are going to code this part, are you going to simulate all these stuff, or you are going to count all these stuff? See, it is not going to happen. But you have to understand another pattern here. See, first pattern that we observed is we can do a XOR of the LH systems together because A is present even number of times. Okay, similarly, another pattern that we can observe here is, see, irrespective, see, the n is going to be between 1 to 10 power 5. Okay, we saw a case when n equal to 2. Okay, when n equal to 2, we saw a case. Okay, the example number 3, in this case also we see that A is present 2 times. Okay, similarly, if we see the case of example number 1, here n equal to 3, and here also A was present 2 times, and every other bit, that's every other variable is present 2 times. So the idea here is, if you take any number, whatever be the n, always you will see that the LHS, when we do the XOR of all the LHS, we are going to see that all of them are going to cancel each other. Okay, because every time each variable will be present two times, so they are going to get XOR with themselves in even number of times, and the result will be always zero for each of those. Okay, so the idea here is whenever you write this for any number of whatever with n, whenever you write this thing and then do a, XOR of LHS, always you are going to get a zero in the LHS. Okay, so that is always there. So the idea here is the RHS also has to be zero. So since RHS is something that we can calculate, it is not something variable. So always the RHS XOR should be zero. If it is not zero, we can say that this is not possible. Okay, so our whole solution is going to revolve around that topic. I hope you are understanding what I'm saying. See this part. Take some more variables. If we saw for n equal to 3, we saw for n equal to 2. You can take the case of n equal to 1 also. Still, you will get to know that. See this. Always and always it will happen that. Okay. Yeah. See this part. Always there will be for each variable there will be another copy of that, because of which the XOR of that will be linked to zero. Okay. Same case will happen for any number of n. Okay. Any n. So we can conclude that always the LHS will be zero. Since LHS is zero, RHS has to be zero. But RHS is something that we can calculate. So we have to calculate the RHS value. That is, we have to take XOR of all the elements given in this. And if the result is not zero, we can say that it is not possible. The original array is not possible, and we have written false. Okay. So that is going to be our logic. Now see this case. I will show you both Python and Java solutions. Now I'm declaring answer which is zero. Remember, doing XOR with zero is not like just multiplying with one. Okay, zero. See, XOR with zero is always equal to multiplication with one. That is, it will not change anything. Whatever is the value, that will remain. Okay, so zero is something best to start with. Okay, as simple as that. Okay. Now, for I'm going through each of the values in the derived array. Okay, I'm calling them I. I'm doing XOR with answer. So this is basically called a shorthand. If you are not aware, this can be expanded like this is equal to answer XOR I. Okay, this is the expanded form of the same. This is called a shorthand in uh, yeah, this is called shorthand basically. This is applicable to all the programming languages, even to Java and Python and C++ also. So yeah, this is called shorthand. So this is the expanded form of the same. So what we are doing is we are taking every I and we are doing XOR of that with answer. Okay, at last we are just checking whether the answer equal to zero or not. If it is zero, then return true. Otherwise, you have to return false. Okay. Let me quickly run this and show it to you. The Java code is also almost same. There is nothing different here. Even in terms of syntax, there are not much differences here. As you can see, this is clearing all the test cases, and I have already submitted this solution. Okay. Similarly, see the case of Java. Same thing, exact same thing. I'm just declaring an integer. Yep. Remember, since answer is only going to revolve around 0 and 1, so it's always fine to take integer. If you want, you can even take, I can say, a boolean and something like that. You can think of those terms. But again, it's not much needed to think too much into that. Okay, I'm just giving you a hint. So yep, I'm going through each of the values in the derived array. I'm doing XOR with I'm doing XOR of each number with answer, and then I'm just returning whether answer is 0 or not. Okay, I'm returning a boolean value true or false, depending on whether answer equal to 0 or not. Okay, I've also submitted the solution, and it was something that was beating 100% of the test cases. Okay, so yep, since we are going through all the elements, this is going to be our fun solution. And if you talk about space complexity, no, we are not consuming any space. Remember, space complexity, when we say, it means in terms of n how much you are consuming. Since our case, it is not going to be dependent on n. Okay, this particular answer is going to revolve only among zeros and ones only. Okay, so it is not, the space it consumes is not dependent on n. Okay, so we can very confidently say it is going to be constant space complexity, that is O of one space complexity and O of n time complexity. So yeah, when this was all about today. This was a very nice question according to me. Okay, so like yeah, by the time, see, I will tell you very frankly, yesterday's question I've solved in detail. For that reason, when I saw this question today, and like till this part I did myself, and then when I saw that the two A's are present, the first thing that came to my mind is I have to do XOR. Okay, so I did XOR, and I got to see that yeah, it is always leading to zero. Then I took some more cases. Okay, I figured out that for every n, this is always going to happen. That for every variable a, there will be another variable a. Okay, always in the LHS. For that reason, I concluded that always the RHS also has to be zero. That's what I wrote it. I did not see the official answer, and still I was able to come to the solution. Okay, so I expect that this could be something that you can also do if you have solved all the questions starting from day 15. Okay, because from day 15 we are having questions on this bit manipulation topic. So please go through them in details. This is always helpful. Okay, see the level that you are coming at, because if you give a normal person this kind of question, I am damn sure even yesterday's question, if you give to a normal person, many of them will not be able to do. Though yesterday's question can also be solved using, even if you don't know the trick, you can still solve them. I have proved the same in my video. Still, I will say this is not something that ordinary coder can do. Okay, only those who have a very good a very good grip on this topic of Bitmarks, they will be able to. So often that was all for this video. And if you like my efforts, please do subscribe to the channel. This really gives us a lot of motivation to continue further. See you tomorrow. Thanks a lot.